For millennia, humans observed the night sky with wonder. The vast expanse of the cosmos, dotted with countless stars, has always been a source of fascination and inspiration. Our ancestors tracked the movements of the sun, moon, and stars, weaving them into myths and legends. They saw patterns in the stars, creating constellations that told stories of gods, heroes, and mythical creatures. These stories were passed down through generations, becoming an integral part of human culture and history. Without telescopes, these celestial objects appeared as points of light, their true nature a mystery. The stars seemed to be fixed in the sky, while the planets, known as wandering stars, moved in complex patterns. The night sky was a canvas of mystery, with each point of light holding secrets yet to be discovered. The known universe was limited to what could be seen with the naked eye: the sun, the moon, Mercury, Venus, Mars, Jupiter, and Saturn. These 7 celestial bodies were the most prominent objects in the sky, and their movements were closely observed and recorded by ancient astronomers. These wandering stars, as they were known, moved against the backdrop of the fixed stars, their paths seemingly erratic and unpredictable. Ancient astronomers noticed that the planets did not follow the same patterns as the stars, leading to much speculation and study. The ancient Greeks developed sophisticated models of the universe, attempting to explain the movements of the celestial bodies. They used geometry and mathematics to create models that could predict the positions of the planets and stars. These early models were the foundation of our understanding of the cosmos. Ptolemy, a Greek astronomer living in Egypt in the 2nd century AD, proposed a geocentric model with the Earth at the center and the sun, moon, and planets revolving around it. This model, known as the Ptolemaic system, was widely accepted for over 1,000 years. This model prevailed for centuries, shaping our understanding of the cosmos. It was a complex system that used epicycles, or small circles, to explain the apparent retrograde motion of the planets. Despite its complexity, the Ptolemaic system was able to accurately predict the positions of the planets, making it a powerful tool for astronomers of the time. However, it was based on observation alone, lacking the tools and mathematical framework to fully explain the intricate dance of the planets. The true nature of the cosmos remained hidden, waiting for the development of new tools and theories to reveal its secrets. The invention of the telescope in the early 17th century would revolutionize our understanding of the universe, allowing us to see beyond the limitations of the naked eye and uncover the true nature of the stars and planets. Before the telescope, ancient observatories were built to study the heavens. These structures, often grand and meticulously designed, were the centers of astronomical research. Astronomers would spend countless nights observing the sky, recording their findings, and refining their models of the universe. They used a variety of instruments to aid their observations, including astrolabes and armillary spheres. These tools allowed them to measure the positions of the stars and planets with remarkable accuracy, providing valuable data for their models. The knowledge gained from these observations was recorded in manuscripts and books, which were shared and studied by scholars across the world. This exchange of information helped to advance our understanding of the cosmos, laying the groundwork for future discoveries. Ancient astronomers also played a crucial role in education, teaching their findings to students and passing on their knowledge to the next generation. Their work inspired countless individuals to look up at the night sky and wonder about the mysteries of the universe. Many ancient civilizations built structures aligned with celestial events, such as Stonehenge and the Pyramids of Giza. These monuments served as both observatories and calendars, helping to mark the passage of time and the changing seasons. Star maps and charts were created to help navigate the night sky, showing the constellations and the paths of the planets. These maps were essential tools for sailors and travelers, guiding them on their journeys across the seas and through the deserts. The stars and planets were also woven into the fabric of ancient myths and legends, depicted in art and literature. These stories help to explain the mysteries of the cosmos, providing a sense of order and meaning to the universe. Through their observations and recordings, ancient astronomers laid the foundation for modern astronomy. Their work, though limited by the tools and knowledge of their time, was a crucial step in our journey to understand the universe. As we look back at the night sky, we can appreciate the incredible progress that has been made since those early days of stargazing. The invention of the telescope and the development of modern science have transformed our understanding of the cosmos, revealing a universe far more vast and complex than our ancestors could have ever imagined. Today, we continue to explore the night sky with ever more powerful telescopes and sophisticated instruments. The legacy of those early astronomers lives on, inspiring us to keep looking up and seeking answers to the mysteries of the universe. The night sky remains a source of wonder and inspiration, a reminder of our place in the cosmos and the endless possibilities that lie beyond. Before the telescope, our understanding of the universe was limited, but the curiosity and determination of those early astronomers set us on a path of discovery that continues to this day. In the early 17th century, a revolution swept through astronomy with the invention of the telescope. This simple yet profound instrument opened up the cosmos in ways that were previously unimaginable. Before its invention, the night sky was a mystery, a canvas of twinkling lights that inspired wonder and speculation, but offered few answers. The telescope changed all that, providing a means to explore the heavens with unprecedented clarity and detail. Galileo Galilei, an Italian astronomer and physicist, was among the first to point this new instrument towards the heavens. Born in 1564, Galileo was a man of many talents, excelling in mathematics, physics, and astronomy. His curiosity and innovative spirit led him to improve upon the basic design of the telescope, increasing its magnification and making it a more powerful tool for celestial observation. With his enhanced telescope, Galileo embarked on a series of observations that would forever change our understanding of the universe. His observations challenged the long-held geocentric view of the universe, which posited that the Earth was the center of all celestial motion. This view, rooted in the teachings of Aristotle and Ptolemy, had dominated Western thought for centuries. Galileo's findings, however, provided compelling evidence for the heliocentric model proposed by Copernicus, which placed the Sun at the center of the solar system. This was a radical shift, one that faced significant resistance from the established authorities of the time. Galileo's telescope, though rudimentary by today's standards, allowed him to see details never before witnessed. It was a simple refracting telescope, consisting of a convex objective lens and a concave eyepiece. Despite its simplicity, it was a powerful tool in the hands of a skilled observer like Galileo. Through this modest instrument, he was able to peer into the depths of space and uncover secrets that had eluded humanity for millennia. He observed the craters and mountains of the moon, shattering the notion of celestial perfection. Prior to Galileo's observations, the moon was thought to be a smooth, unblemished sphere, a perfect celestial body. Galileo's detailed sketches of the lunar surface, however, revealed a rugged landscape, pockmarked with craters and dotted with mountains. This was a profound revelation, one that challenged the prevailing view of the heavens as a realm of perfect, unchanging forms. He discovered 4 moons orbiting Jupiter, demonstrating that not everything revolved around the Earth. These moons, now known as the Galilean moons, were Io, Europa, Ganymede, and Callisto. Their discovery was a significant blow to the geocentric model, providing clear evidence that celestial bodies could orbit objects other than the Earth. This was a crucial piece of the puzzle, one that helped to solidify the heliocentric model and pave the way for future astronomical discoveries. His observations of the phases of Venus provided compelling evidence for the heliocentric model, with the Sun at the center of the solar system. By carefully tracking the changes in Venus's appearance, Galileo was able to show that it exhibited a full set of phases, similar to those of the Moon. This was only possible if Venus orbited the Sun rather than the Earth, providing further support for the Copernican system. Galileo's discoveries marked a turning point in our understanding of the universe. They challenged the established order and forced a re-evaluation of long-held beliefs. His work laid the foundation for modern astronomy, inspiring future generations of scientists to continue exploring the cosmos. Galileo's legacy is a testament to the power of observation and the importance of questioning established paradigms. The telescope, once a novelty, became an essential tool for astronomers, extending our vision beyond the limits of the naked eye. Over the centuries, telescopes have evolved, becoming more powerful and sophisticated. From the simple refracting telescopes of Galileo's time to the massive reflecting telescopes of today, these instruments have allowed us to explore the universe in ever greater detail. Modern telescopes, equipped with advanced optics and digital sensors, can capture images of distant galaxies, nebulae, and other celestial phenomena with stunning clarity. However, while Galileo's observations revolutionized our view of the heavens, the underlying laws governing the motion of celestial bodies remained a mystery. It would take the work of later scientists such as Johannes Kepler and Isaac Newton to uncover these laws and provide a comprehensive understanding of the forces that govern the cosmos. Kepler's laws of planetary motion and Newton's law of universal gravitation built upon Galileo's observations, creating a framework that has stood the test of time. Together, these discoveries have given us a deeper understanding of the universe and our place within it, continuing the legacy of exploration and discovery that Galileo began. Thank you for watching. If you enjoyed this video, please leave a comment, like, and subscribe to our channel for more fascinating content about the universe. Your support helps us bring you more exciting discoveries and insights. Until next time, keep looking up at the stars.